Hi there and welcome to my channel. So in this video we are going to discuss how we can calculate the minimum cost or how we can calculate the shortest path from one given vertex to all the remaining vertices of a graph. Okay, we can do this with the help of various minimum cost algorithm. Now in this video we are going to discuss about the Dijkstra algorithm. Before moving further, let's just have a look at the definition of Dijkstra algorithm. Dijkstra algorithm is used to find the shortest path from the single source vertex to all the other vertices in a weighted, directed or undirected graph. Now, what do I mean by Dijkstra algorithm? In this algorithm, we are going to calculate the cost from one given vertex to all the vertices in a graph, but the cost should be minimum cost. Okay, so that is why we call it as a minimum cost algorithm. Now, whenever I'm saying graph could be a weighted directed graph or it could be a weighted undirected graph, but it has to be weighted, right? Since we are saying we are going to calculate the minimum cost, first of all, we should have cost. So that is why we are saying this is going to be a weighted graph. But there is a condition with Dijkstra algorithm that all the weights are going to be positive weights, or we can say the weights must be non-negative. Why? That we'll see with the help of example. Why weights has to be non-negative every time. Okay. Now there is another definition of Dijkstra algorithm. It is used to find the shortest distance or the minimum cost in a weighted, directed or undirected graph. In this, we are actually working in the backward direction. Now, what do I mean by backward direction? That we are calculating the cost from the end to the beginning. And at every step, we are calculating the shortest distance. But before moving ahead with the Dijkstra algorithm, firstly, we should know how to calculate the cost or how to calculate the distance of a vertex with some another vertex. Let's just have a look. These are the three vertices in my graph. Now there has to be a source vertex, as we have read in the definition of Dijkstra algorithm that we are going to calculate the cost of source vertex to all the remaining vertices. So there has to be a source vertex and we are assuming that A is the source vertex. Okay. Now from A to B the weight is 4 and from B to C the weight is 6. Okay. Now I'll let you know how to calculate the cost of B vertex and the C vertex, or how to calculate the distance of vertex B from A and distance of vertex C from A. First of all, we should know that from A to B, what is going to be the distance? That is 4 only. So I can write distance of B as 4. Now from A to C, there is no direct edge. Okay, so that means I'm assuming distance is going to be any number. Since in mathematics infinite is a number which is having the maximum value, so we are assuming that this distance is going to be the maximum distance. Okay, and we are going to update it. Okay, right now this is the maximum distance. So in short, what I am saying, the vertices which are directly connected to the source vertex write down the cost, and the vertices which are not directly connected to the source vertex write down the infinity for those vertices. Okay, now we are going to calculate. See, directly there is no path from A to C, but indirectly, yes, I can come to C via B. That means I can traverse from A to B and then from B to C. Okay, so what we are going to do, we'll consider this vertex as intermediate vertex. Okay, now what is the cost of this vertex? That is 4. And what is the distance between B to C? That is 6. So 4 plus 6 total, it will give me 10. Now since we are working with the minimum cost algorithm, so we are going to choose the minimum cost between infinity and 10. Now 10 is going to be the minimum cost, so we are going to replace this infinity with 10. Okay, see what we have said, that if there is no direct path, write down infinity for that vertex and then try to calculate the cost of indirect path and then compare the cost of direct path vertex and indirect path vertices. If indirect comes out to be less than the direct, then we are going to replace it. Okay, so this is what we have written. There exists a direct path from vertex A to B, which is costing 4, and there exists an indirect path from A to C, which is costing 10. Now, let's just have a look at the example of Dijkstra. Here we are going to deal with the graph, which is going to be a directed weighted graph. Okay, since I'm saying directed, so we are going to have directions in our graph. Now we are also saying this is a weighted graph, so every edge is going to contain some weight. Okay, Now let's just understand how we are going to deal with this problem. First of all, I'll let you know about this formula later. First of all, let's just understand we are going to make a table. In this table, we are going to have n minus 1 vertices. What do I mean by this? If I have 6 vertices in my graph, I'm going to have only 5 columns in my graph. Okay. Now, why 5 column? Because the vertex which we are going to treat as the source vertex, we are not supposed to write down that vertex in this table. Okay, so that is why if there are n vertices, we are going to write down n minus 1 vertices in our table. Source vertex would be excluded. So here we are saying A is the source vertex. We are assuming that A is the source vertex. So we are going to write down every other vertex apart from the source vertex, which means B, C, D, E, N. First of all, we are going to check who is the neighbor of source vertex. Now here the source vertex is going to be A. So we are going to check the neighbor of A. So B is the neighbor of A. What is the cost of A to B? That is 2. So I'll write 2 here. Now A to C. C is not the neighbor of A, direct neighbor of A. So we are going to write down infinity. Now A to D. D is the direct neighbor of A and the cost is going to be 4. A to E. They are not directly connected. So we are going to write infinity. A to F not directly connected. So we are going to write infinity. This is the very first step, the basic step that we have done with the previous example also, how to calculate the direct cost and indirect. Firstly, we have written the cost of all the vertices which are directly connected to the source vertex, and rest all other vertices we have assigned infinity to them. Okay. We are going to deal with the neighbors of next vertex, but who is going to be the next vertex? The vertex which is going to have the minimum value, since we are going to deal with the minimum cost. So out of all these values, 2 is in minimum. So we are going to choose the vertex B. Okay, we are going to choose the vertex B. So we'll write B here. This is your selected vertex. There is also one point that you have to remember. Once a vertex has been chosen, we are not going to work on that vertex again. And we are assuming that this vertex has this minimum cost. We cannot get a cost for this vertex less than 2. Since we are choosing this, so we are assuming also that at this point, this vertex can have minimum this much cost. Now we are going to look at the neighbor of B. Now, what is the distance of vertex B? It was 2. And what is the cost of vertex B to C? It is 7. So 2 plus 7, it will give me 9. Okay, now we are going to apply this formula. Firstly, we'll check the distance of one particular vertex. If I am assuming this is my vertex U, this is my vertex V. So we'll check for the distance of vertex U. Why we need to check the distance of U? Because this is not the source vertex. This vertex is not the source vertex. So that is why we need to check the distance of this vertex from the source vertex. Because we are supposed to calculate the cost of source to the all other vertices. Okay, so that is why we need to check the distance of this vertex plus the cost between U and V. Okay, and that would be the final distance of V vertex. If this comes out to be less than the initial cost of vertex V, then we need to replace it. This is what we have written. If distance of U plus cost of U comma V is less than distance of V, then replace it. Okay. Now 7 plus 2 gives me 9 and 9 is less than infinity. So that is why we need to replace it. Okay. Who is the other neighbor of B, which is D? Now, what is the cost of B, which is 2, and what is the distance of B, which is 2, and the cost of B to D is 1. So, 2 plus 1 will give me 3. What is the cost of D already I have? That is 4, but 3 is less than 4. So, we are going to replace it. Although A was directly connected to D, but it's okay. If I traverse it indirectly, cost comes out to be less. So I need to have less cost. It doesn't matter whether I am going directly to that vertex or through some another vertex. The main target of my algorithm is to find the minimum cost. Now 3 is less than 4, so we are going to replace 3 with 4. Now B is not directly connected to E. I can't change the cost of E. B is not directly connected to F, I can't change the cost. Okay, so these will remain as it is. Now out of all these values, 9, 3, infinity, infinity, which is less value, that is 3. So this time I'm going to choose vertex D as the next vertex. Okay, so we'll choose D vertex as the next, and we are going to write D as the selected vertex. Once I have chosen, I cannot perform the operation on this vertex. I have chosen B, I cannot work on this vertex again. I have chosen D, I cannot work on this again. Okay, now I'm going to look at the neighbors of D. See, B is not a neighbor of D. Why? Because there is a path from B to D, but vice versa is not true. But D is connected to E. What is the cost from D to E? What is the distance of D, which is 3? What is the cost from D to E, which is 3 again? So 3 plus 3 will give me 6. And what is the cost of E? Already I have, that is infinity. 6 is less than infinity, so I am going to replace that. Okay, this is, I have written the same thing, that is 7 plus 2, it will give me 9. Now, D is not directly connected to F, so we cannot update the cost of it, so we are going to write infinity as it is. Okay. Now B we have chosen, D we have chosen, we cannot write them again, we cannot perform operations on them again. So here we are going to have only 3 vertices left, that is C, E and F. Out of C, E and F, which is having the less cost, that is E. So we are going to select now E. Okay, E is going to be the selected vertex now. So we'll write E here. Okay, now we are going to look at the neighbors of E. Who is the neighbor of E? One is C, one is F. What is the distance of E? I have 6. And what is the cost from E to C? That is 2. So 6 plus 2 will give me 8. But earlier, how much cost I have? That is 9. So we are going to replace this. I'm getting a path which is costing me less. So definitely I'll go with that path. Okay. Now, who is the neighbor of E? That is F is also a neighbor of E. What is the distance of E? That is 6. And what is the cost of E to F? That is 5. So 6 plus 5 will give me 11, which is less than infinity. So we are going to replace this. Clear? Now we have chosen B, we have chosen D, we have chosen E. Out of C and F, which is minimum, this is minimum. So we are going to choose C now. Okay. When we choose C, now who is the neighbor of C? That is F. F is the neighbor of C. So we are going to work on this again. Now what is the distance of C? That is 8. And what is the cost from C to F? That is 1. So 8 plus 1 gives me 9. And what is the early distance of F? That is 11. So 9 is less than 11. So we are going to replace this. So this is how my Dijkstra algorithm works. If I need to specify the cost of vertex B is going to be 2, cost of vertex D is going to be 3, cost of vertex E is going to be 6, cost of vertex C is going to be 8, and cost of vertex F is going to be 9. And visually also, if you have a look at the graph, there is a way to traverse from A to F, and the way is costing me 2 plus 7 plus 1, total of 9. There is one more way which is costing me 4 plus 3, 7 plus 5, 12. Definitely I'll follow the path which is costing me less. In this way, we can calculate the minimum cost from the source vertex to all the other vertices in a graph. In the next video, we are going to explore why Dijkstra algorithm is not working for the graphs having negative weight. If you like this video, please don't forget to hit the like button, and if you haven't subscribed to my channel, please do that now. Stay tuned, be safe, be happy, and let's just meet in the next video. Bye bye.